As a species, we stand out because of our capacity to think in unique ways. We know things in ways that no other species on Earth is capable. But individually, we suffer from many misconceptions about what we know and how we know it. Some have called these misconceptions illusions because they're so widely shared and so hard to shake. In this video, we're going to explore some of these illusions. Our title, The Knowledge Illusion, is inspired by a recent book of the same name by cognitive scientists Stephen Sloman and Philip Fernbach. Some of the examples we'll look at are discussed in early chapters of this book, but the authors are summarizing work done by a number of different researchers, as we'll see. Let's start with a simple question. Do you know how a bicycle works? Do you know what a functioning bicycle looks like? Let's quantify this a bit. If I asked you this question, how would you answer? On a scale of 1 to 7, how well do you understand how bicycles work? 1 represents the lowest level of understanding, 7 the highest. Or, if this helps, you could say, the lower end of the scale represents a very shallow understanding. The middle range represents partial understanding, and the upper range represents deep understanding. Okay, now let's test your knowledge. Here's a sketch of a bicycle. It's got some missing parts. There are parts of the frame missing. There are no pedals, and there's no chain. So your task is to complete the sketch by drawing in the missing parts so that the resulting picture describes a functioning bicycle. And to simplify things, let's use these conventions. Use straight lines for the missing parts of the frame, use this pedal graphic to represent the pedals, and use a dotted line to draw the loop of the chain. I invite you to pause the video right now and pull out a piece of paper and a pencil and try this exercise without looking at a reference, just off the top of your head. It sounds like an easy enough task, but like I said, I encourage you to actually try it. Now here's a different version of the test, multiple choice. We'll work through the bike in stages. Of these 4, pick the drawing that best describes the frame of a functioning bike. One of these choices is correct. Remember, at any time you can pause the video if you like. Now let's do the pedals. Where do the pedals go on a bike? One of these is correct, the others are wrong. And finally, the chain. Which configuration will give you a functioning bicycle? Now, as you might have suspected, this was a real experiment done with real people. A group of over 200 undergraduate psychology students, in fact. But before we get to the results, let's take a second look at that earlier question. Having gone through this exercise and thought about it a bit, on the same scale of 1 to 7, how would you rate your understanding of how bicycles work? Okay, now let's look at some examples from our undergraduate students where they had to draw in the missing parts of the bicycle. Here's one where the pedals are attached to the front wheel and the chain goes around both wheels. And notice, if you think about it, that you can't turn the wheel with this arrangement. It'll knock the chain off. Oh, and by the way, this study group was quite familiar with bicycles. Within this group, over 96% had learned to ride a bike as children, and over 50% of this group currently owned a bicycle. And of course, most of us see people riding bicycles on a regular basis. We have for years, even if we don't ride one ourselves. So it's a familiar machine to most people. Here's another one. Yes, someone put the pedals up there. And again, the chain is going around both wheels. This one is lovely, but the chain again is around both wheels. Same problem again here. And we've got pedals again on the front wheel. These bicycle configurations just won't work. Now just to refresh your memory, here's what a real bicycle looks like. The pedals attach to the frame in between the wheels, and the chain loops around the axle of the back wheel and the crank of the pedals. The chain always stays aligned with the frame of the bike, and the front wheel can turn freely. Now, you might think that you would do fine on this test, but let's look at the results of the study. We can thank psychologist Rebecca Lawson at the University of Liverpool for this great illustration of the knowledge illusion. It turns out that about half the students in her study were unable to complete the drawings correctly. Some errors were more common than others. The chain seemed to be the hardest to get right. Not surprisingly, they did better when given the multiple choice options, where one of them was the correct answer. But even here, the rate of mistakes was much higher than you would expect. She did the test with a group of regular cyclists from a local cycling club, and thankfully, the error rates were much lower among this group. These are people who pay attention to how their bicycles operate. They've changed tires and fixed chains with their own hands. And here's a remarkable result. She did the test with a group of non-cyclists, people who don't regularly ride a bicycle or own a bicycle. and she gave them a real bicycle to look at, to reference, while completing the drawing. And there were still a decent number who made mistakes. 12% from this group did not get the chain right. Now, what about the confidence that people have in their understanding of how bicycles work after they've gone through the exercise of trying to explain how they work? Well, Rebecca Lawson didn't actually measure this explicitly in her study, but there are many studies that do measure shifts in confidence when asked to explain how something works. The general effect is that a statistically large percentage of people start off with a higher estimation of their understanding, and then they come to realize that their understanding is in fact more shallow and incomplete than they had thought, and they revise downward. So someone estimating a 6 to begin might revise downward to a 3 afterward. And people are generally surprised at their inability to explain how this familiar thing works. They didn't expect this. You see this surprise in the comments of many of the students who took the bicycle test. Thinking about it in more detail, I realized I had no idea about its structure. I thought I knew more about the workings than I actually did. I can't believe I found it so difficult to remember what a bike frame looks like. I never knew how little I knew about things until I had to draw them. This phenomenon has been called the illusion of explanatory depth. We think our understanding is deeper than it is. Again, it's a statistical effect, so it doesn't affect everyone equally, but it is a strong effect. You'll see it if you ask people to explain how a zipper works, how a flush toilet works, how piano keys work, how a speedometer works, how a sewing machine works, how almost any common device with visible parts works. If we don't actually work with these things on a regular basis, our tendency is to dramatically overestimate our understanding of them. You also see this effect if you ask people about their understanding of more abstract but otherwise common topics, like how compound interest works, what a genetically modified organism is, what are the parts of an atom and how are they organized, how the greenhouse effect works, what the symptoms of depression are. This illusion of understanding, this knowledge illusion, appears for just about everything. Now, I want to clarify that the point of these demonstrations is not to show that we're ignorant. The point is to show that we're more ignorant than we think we are. We're subject to an illusion of understanding, an illusion of knowledge that makes us overconfident about what we know, more confident than we should be. Now, at this point, it's reasonable to ask, what am I supposed to do with this information? How is knowing about the knowledge illusion going to help me become a better critical thinker, a better argument ninja? Well, there's actually a lot that we could say about this, but for now, I'll just point out two things. The first is that becoming aware of our vulnerabilities and our limitations as thinkers, as cognitive agents, is an important part of the process of improving the quality of our thinking and decision-making. We need to know what our limits are and the limits of other people so that we can develop strategies for avoiding the problems that come with overconfidence. The second point is that now that we're aware of the knowledge illusion, we're in a position to ask a question that would never have occurred to us before. The question is, why are we subject to this illusion? Why is it so central and so pervasive? Actually, this is the central question of the book by Stephen Sloman and Philip Fernbach, and the subtitle of the book hints at the answer. The Knowledge Illusion, Why We Never Think Alone. We never think alone. We're going to talk about this more as we move through the Argument Ninja program, but here's the basic idea. We as individuals actually store very little detailed information about the world in our brains. To solve problems and to guide action, we sample information contained in our brains, but we also sample information contained in our bodies. Our bodies are constantly relaying information about our internal state and our physical situation back to our brains. Our thoughts and feelings and conscious mental states all depend on information flow between the brain and the body. And not just the body. Human cognition also exploits information in the environment outside the body. If I want to know what's behind that tree, I can move my body to sample new information. I don't need to represent all of that information in my head. And when it comes to knowledge and thinking, human beings store vast amounts of knowledge outside our brains and bodies, in artifacts, in information systems, which we'll learn to access when we need it. The fact is that cognition isn't something that happens solely within the confines of our skulls. brain activity and cognition are not the same thing. Brain activity is necessary for cognition, but cognition, thinking, perceiving, remembering, imagining, feeling, is not a property of brains in isolation from their environment. It's a property of brains situated in and dynamically interacting with bodies, which are themselves situated in and dynamically interacting with environments. And there's one more important level that we need to include. We also store information in other people. I don't need to know everything about bicycles if all I want to do is ride them. If I need to know more, there are people I can ask. If I need my bike fixed, I know that there are experts who can do that for me. What I need to know is how to access this knowledge, this expertise that is stored in the community. This division of cognitive labor is central to how human societies work. And at an even higher level, there's the information stored in the culture at large, in our language, in our institutions, in our literature, in the media, in the diverse knowledge practices of humanity, the ecosystem of information and ideas that is continually expanding, and that we are now learning how to access in a usable form through technology like the internet. Now, with this new perspective in mind, we can see why the knowledge illusion is so pervasive. The fundamental mistake is that we think about personal knowledge, what I know, what you know, in terms of what's inside our heads and what we can articulate and explain at any given moment, without any supporting aids or access to outside sources. This is a mistake because it assumes that there's a sharp line between knowledge that is inside and outside our heads, but there is no sharp line. Another way to put it is that we fail to realize that all the knowledge available to us in this picture is not available to us in this picture. And we're surprised to discover this. We're surprised to discover that, on our own, we can't explain how a bicycle works. The truth is that we, as individual human beings, in isolation from the environment and the community of fellow human beings, have only a fraction of the knowledge and intelligence that is available to us through our participation in the collective mind, the hive mind of society and culture. This is where the brilliance of humanity is located, in the extended mind of community, technology, and culture. Now, if you want to read more about this whole approach to studying knowledge and learn more about some of the interesting details about how we make judgments about what we know, I do recommend the book by Stephen Sloman and Phil Fernbach. In the context of the Argument Ninja program, one of my goals in these white belt lessons is to lay a foundation for future learning. And an important part of that is developing awareness. In this case, awareness of our cognitive limitations and the limitations of other people, and awareness of how our minds work, so that we can be in a better position to develop strategies to avoid errors, improve our thinking, and become more effective persuaders and communicators.